This is Naresh, working as an assistant professor in AC department. And today we are going to discuss the course description on outcome-based education, that is OBE. So in this session, we are going to discuss what is outcome-based education and how to frame the objectives and how to frame the outcomes for these electronic devices and circuits, and how it is relevant to the program outcomes and program-specific outcomes. Then later we'll discuss what is the syllabus for this electronic devices and circuits. So actually, what is the outcome-based education? So actually, the outcome-based education is a student-centric teaching and learning methodology in which the course delivery and assessment are planned to achieve the stated objectives and outcomes. So this describes means how. So what are the objectives and outcomes are we frame? How it is suitable to this subject? Then how it is really matched to this while delivering the course. And based on that, we identify that it mainly this outcome based, so mainly focus on the student performance, that is outcomes at different levels. Means how the student gains the information from this course. So for that case, we are going to measure the student performance by using the different types of the levels. So why this outcome-based accreditation? The understanding the fundamentals very well and learning. So to learn the new skills or competences. So based on this learning of these new skills and the competences, the student should be enabled to learn the some scope, means where the demands are rapidly changing in the workspace. So means from this we can learn so where we are lagging and what are the tools and what are the parameters are required to gain our knowledge. So that is the reason we are going to discuss this understanding and the fundamentals very well and learning new skills or competences that would enable individuals to cope with the demands of the rapidly changing the workplace. Then then we need to prepare a global engineers who will have to solve the problems and shoulder challenges which are not even known today. So some important aspects of the outcome-based education. So in the first one is a course. The course is defined as a theory or a practical or a theory come practical subject so studied in a semester. So for this case, our subject is electronic devices and circuit. So this electronic devices and circuits, this comes to theory come practical related subject. So from this, what is the course outcome defines? The course outcome is like a CO. So what it indicates, what is the course outcome indicates? The course outcomes are the statements that describes the significant and essential learning that learners have achieved and can reliably demonstrate at the end of a course. So it simply statement means it defines the statements what the learner can achieve from that topic and what we are going to demonstrate or what we are going to means where we are going to applicable that statement at the end of the course that indicates the outcome of that subject. Then another important aspect is a program. So here the program is defined as a specialization or a discipline of a degree. So it is an interconnected arrangement of the courses, means as well as the co-curricular and extracurricular activities to accomplish the predetermined objectives leading to the awarding of a degree. So while defining the program, so it is specifically related to the particular degree, means complete, if you take our BTech, that is a BTech degree. So while designing this course, it interconnects the arrangement of the courses as well as the co-curricular and extracurricular activities to define the objectives of the degree to awarding of a degree. So then from that program, now we are going to define the program outcomes. So here the program outcomes are the narrow statement that describes what the students are expected to be able to do by the time of graduation. So based on that, and again another aspect is a program educational objectives PEOs. So here the program educational objectives of a program are the statement that describe the expected achievements of the graduates in their career, and also particular what the graduates are expected to perform and achieve during the first periods of after graduation. So based on these program outcomes, then we need to define the program educational objectives. So these program educational objectives are defined the statements of the program that define what are the expected achievements of the graduates in their career, as well as after completion of the data after the first few years, what we are going to do. So what are the expected outcomes, what are the achievement you are going to do? That should be described by the program educational objectives. Then the program specific outcomes. So these program specific outcomes are related to department. So specific program. So means either electronics and communication like that. So here these are the outcomes are what the students should be able to do at the time of graduation with respect to specific discipline. So maximally we have 2 to some 4 PSOs for a program. And coming to program outcomes, we have the 12 program outcomes. The first one defines engineering knowledge. Second one defines the problem analysis. Third one is design or development solutions. Fourth one is conduct investigations of the complex problems. Fifth one is a model tool usage. Sixth one is the engineer and the society. Seventh one is environment and sustainability. Eighth one is the ethics. And the ninth one is the individual and the teamwork. 10th one is the communication. 11th one is project management and finance. And 12 is a lifelong learning. So these are the program outcomes, 12 program outcomes. Now coming to our course. So here our course is electronic devices and circuits. So here I'm going to show that what is the overview of course means. This indicates the in detail of a particular subject, what we are going to discuss in this subject. So this course provides the construction features and the principal operation of the basic semiconductor devices. Means we have some level devices like diodes and transistors. So in the transistor we have again bipolar and unipolar transistors, and some special purpose devices like a silicon control rectifier or like that. So that is the reason. The first, it describes the construction features and the principal operation of the. So means what is the functionality of the device and how we are going to construct that device. Means if you observe that a PN junction diode, so how we are going to make the PN junction diode, how we are fabricating it. So what is the behavior of the PN junction diode. So that should be all these to be we are going to demonstrate in this. Then again, it is intended to provide the different biasing configurations of the semiconductor devices to provide a temperature stability. So means what are the biasing configuration? Suppose let's take one example we taken as a transistor. So means the transistor is acts as a majorly has two applications, switch and amplifier. So means if you want to work with the amplifier, we need to maintain a proper Q point or operating point. To maintain this proper Q point, again we require externally bias. And similarly, suppose if I have a semiconductor, so means we have some PN diode, some xenon diode. So to identify the behavior or to identify the functionality of this one, so externally we need to apply some force. The way of approaching this force is nothing but your biasing. So that is the reason. So by using this biasing concept, we need to identify the behavior and the characteristics of that particular device. And after that, the analytical skills to configure a semiconductor device for the applications. So means after this, so first we are going to discuss the construction, and then we identify the behavior, then we identify the properties of the particular devices, then we identify the characteristics. After that, so where we are going to use these devices means in application. So that is the reason. For these applications, you can build with these applications like rectifiers, clippers, and regulators, clampers, as well as amplifiers by using these special semiconductor devices. So that is the reason. The operation principle, based on these operation principles and the characteristics of the semiconductor devices and circuits for rectification and amplification and conditioning and voltage regulation of signals. Then the analytical skills are needed to model analog and digital integrated circuits at discrete and micro circuits. So after that, if you learn some construction and if you learn the characteristics and the behavior and the application, then you can design some to model a circuits or analog circuits or a digital circuits. Like suppose we need to take, if you define some a amplifier, so means first we need to define how to design this amplifier, what are the components or what are the devices are required. So and before that we need to know the properties and functionality of the particular device, then only we can applicable to particular application. So that is the reason the analytical skills are needed to model analog and digital integrated circuits at discrete and micro circuits level. Then, so these are the course objectives. These are the three course objectives. The foundations of the basic electrical circuits necessary for building complex electronic hardware. So these are the three course objectives. So first objective is the operational principles, characteristics of the semiconductor device circuits for rectification, amplification, condition voltage amplification. The second objective is the analytical skills are needed to model analog and digital integrated circuits at discrete and micro circuit level. And the third objective is the foundations of basic electron circuits necessary for building complex electronic hardware. Then we see what are the course outcomes for these electronic devices and circuits. The first outcome is to illustrate the characteristics of semiconductor devices for determining the device parameters such as resistances, current gain, and voltage gain. Suppose if you take here the diode, so diode we have some two characteristics. So forward bias characteristics and reverse bias characteristics. From these characteristics, we need to find out that some parameters like static resistance, dynamic resistance. So again, we need to find a dynamic forward and a dynamic reverse resistances. Let us take if with some transistor, we have some configurations like common base, common emitter, and a common collector. From this, we need to find out the gain parameters, means voltage gain or a current gain. And the second outcome is apply this PN junction characteristics for the diode applications. Means, so the first outcome we learn how to identify the characteristics, and based on the characteristics we add some parameters here. Now we need to use this characteristics principle to build some applications like some switch rectifiers, clippers, and clampers. So all these applications are built with a normal PN junction diode. They are the applications for a semiconductor diode. And the third one is examine DC and AC load line analysis of BGT and FET amplifiers for optimal operating level regardless of input and load placed on the device. So in general, we know that so if you take another semiconductor device like BJT, bipolar junction transistor, or a field effect transistor, and most of the cases these two devices are used for amplification process. Hence, the applications of this bipolar junction transistor and the field effect transistors are amplifiers. To satisfy these amplifiers, we need to maintain a proper Q point. To identify this Q point, we need to identify the DC load line analysis as well as AC load line analysis. So that is the reason. Examine the DC and AC load line analysis for bipolar junction transistors and field level transition amplifiers for optimal operating level. Means this is optimal operating means a proper Q point we are going to find out irrespective of input and a load placed on the device. Then the fourth outcome is extend the biasing techniques for bipolar and unipolar transistor amplifiers. So in the previous outcome, we identify the biasing is a required, or DC biasing is a required to maintain a proper Q point. So for this case, what are the biasing techniques we need to follow to maintain a proper Q point or to maintain a proper stability condition to achieve the proper operating point? So that is the reason. So we need to discuss some of the biasing concepts or what are some biasing techniques to maintain a proper stability point or a proper Q point. So that is the reason. Extend the biasing techniques for bipolar and a unipolar transistor amplifier circuits, considering stability condition for establishing a proper operating. So let us take some examples like we have some biasing conditions: self bias, voltage divider bias, and emitter to collector base bias, like that fixed bias. So these are the biasing approaches to maintain a proper Q point or to stabilize the Q point. And next, fifth outcome is utilize a low frequency model for estimation of the characteristic parameters, the BJT and FET amplifiers. Means, so we need to identify the low frequency analysis or small signal model by using the H parameters for a case of BJT. So by using this H parameter, we have some parameters like input impedance and reverse voltage gain and forward current gain and output impedance, where HI is input impedance and HR means reverse voltage gain, HF means forward current gain, and this is output admittance. So we need to define the small signal model to identify the low frequency analysis for this BJT and FET. So in the case of the FET, we can identify that amplification factor, mu, and transconductance, and internal drain resistance. And the last outcome is, the sixth outcome is the demonstrate the working principle of a special semiconductor diodes, like the special purpose diode means like a xeno diode. We have some tunnel diode and silicon control rectifier and the varactor diode. So like, and the transistors means some unijunction transistors. So on this, now we are going to discuss what is the working principle of all these special purpose devices, diodes and the transistor for triggering and voltage regulation applications. Means the voltage regulation means xeno diode is also as the voltage regulator. SCR also as the voltage regulator for triggering points to change the state of tunnel diode and UJT diode. So these are the 6 course outcomes are defined for electronic devices and circuits. Now we'll discuss what is the CO and the PO, means course outcome and a program outcome relationship. So for this case, each CO can be identified to address a subject of program outcomes. Based on the number of course outcomes and sessions dedicated to them, it is possible to identify the strength of the mapping. So we need to view the strength of the mapping, either 1 or 2 or 3. Based on the strength of the selected POs, a course outcome matrix can be established. So means whatever the course outcomes we define, that should be matched to the particular program outcome. So based on this interconnecting of this course outcome, the program outcomes, then we need to define the strength, how it is relevant to that particular program outcome. The strength should be in terms of either 1, 2 or 3, where 3 is the maximum, 1 is the minimum. Based on this given strength, we need to identify the articulation matrix, course outcome articulation matrix we need to establish. So let us take, so we are initially we discussed that we have the 12 program outcomes, but here I mapped only 4 program outcomes to our course, electronic devices and circuits. So in that I taken as Out of those 12 program outcomes, I considered PO1, PO2, PO3, and PO10. So we know that the PO1 is engineering knowledge. So this is required to understand the characteristics and some construction principles like that. And the PO2 is a problem analysis, means based on that we need to define some applications like rectifiers and amplifiers or clippers. Then we need to design or development solutions are also required. So suppose if you want to design a switch, or if you want to design some amplifier, or if you want to design some voltage regulator, we require this PO3. Then communication means to define a proper representation for your circuit. Then we require also communication. So here I taken as a strength 0. So for PO1 I given the strength maximum strength is a 3, PO2 is a 2 strength, and PO3 is a 2, PO10 is a 1. All these to be accessible by either your examination, semester examinations, or CA examination, or AET. Then how program specific outcomes are accessed. So we have actually in our department we have the 3 program outcomes. So in the 3 program outcomes, our these electron devices and circuits are related to only one PSO, that is PSO1. So the PSO1 is build embedded software on a digital circuit development platform for robotics, embedded systems, and a signal processing update means. To define with all these programs, we require some electron circuits. So that is the reason I map this one. The strength I given as a. So this is mapping of each CO with program outcomes and as well as program specific outcomes. So we define the 6 course outcomes and I mapped with so we used only the 4 program outcomes, PO1, PO2, PO3, and the PO10, and the PSO1 is the only one. So means how these course outcomes are relevant to these POs. Based on the defined course outcomes, I mapped the CO1 to PO1 and the PO2 as well as the PO10. The course outcome 2 is mapped with the PO1, PO2, PO3 as well as the PO10 as well as the PSO1. So like that, CO3 is a course outcome 3 is mapped with the PO1, PO2 and the PO10. And the course outcome 4 is mapped with the PO1, PO2, PO3 and the PO10. Course outcome 5 is mapped with the PO1, PO2 and the PO10. CO6 is mapped with the PO1 and the PO10. So then in that we have the 5 modules. So the module 1 contains diodes and applications. In that we have, so in this module we are going to discuss what is a diode and how to calculate the static and dynamic resistances and what is the equivalent circuit. Then we need to discuss load line analysis. Based on this diode conduction, we have the 2 types of the capacitances, that is diffusion and transition capacitances. After that, we will discuss. So this kind of describes diode applications, means where we are going to use this diode. So majorly, so we can use it as a switching as well as some of the applications like rectifier, then clippers and clampers. So in these rectifiers, we have the 3 types of the rectifiers: off-wave rectifier, full-wave rectifier, and a bridge rectifier. Along with some filters concepts also we need to discuss here. Then clippers. Then in the clippers we have the clipping at 2 independent levels and clamping, what is the clamping operation, and types, clamping circuit theorem as well as the comparator. So this is module 1. So module 2 describes the bipolar junction transistor and the semiconductor device. So in this module we are going to discuss the construction and the principal operation of the bipolar junction transistor. Based on that, we'll discuss some configurations like common emitter, common base, common collector configuration. Then we need to define some Q point. For this to define a Q point, we need to identify this DC and AC load line analysis, as well as we need to discuss a small signal model that is also called as a hybrid parameter model. So then we need to realize this a small signal model from the bipolar junction transistor. From that, we need to calculate the H parameters from the 3 different configurations: common emitter, common base, common collector. And we need to also discuss how to convert from one configuration to the another configuration, like common base to common emitter, or common emitter to common collector, or common collector to common base line. Then module 3 describes the transistor biasing and stabilization. So in this module 3, so in the previous module we identified that only the Q point, how we are going to define the Q point. Further gate, what are the DC biasing and the DC loading analysis are required. So based on that, here we are going to define what are the biasing techniques are required to maintain a proper stabilization. So hence we have the different biasing configurations for a BJT, like some fixed bias, collector to base bias, and a self bias. Then we have some bias compensation, diodes and a transistor. Then after that, we need to discuss the small signal analysis of the BJT amplifiers. So in this case, we need to discuss the analysis of all three configurations. We have the three configuration: common emitter, common base, and common collector. So each configuration is acts as amplifier. So hence the analysis of common emitter, common collector, common base amplifiers, along with out of these three, so the most important configuration is a common emitter amplifier. So hence the CE amplifier with emitter resistance, as well as the low frequency response of the BJT amplifiers. Then we'll need to discuss what is the effect of what happens while you are placing the coupling and the bypass capacitors on a CE amplifier. Then the module 4 describes the junction field effect transistor. So in this module, we are going to discuss the construction principle of field effect transistor. So hence, how we are going to construct the field effect transistor, what is the principle of that operation. From that, we need to identify the characteristics of that FET. So then that is nothing but a volt ampere characteristics. Then we need to compare, means based on these characteristics, so we need to analyze, so what are the BJT characteristics and what are the FET characteristics, and where we are going to use that BJT and the FET life. Then after that, we'll discuss the biasing of FET. And another name is the FET is also acts as voltage variabilized. So generally here actually in this field effect transistor, we have the two types of the FET. One is junction field effect transistor, another one is MOSFET, means metal oxide semiconductor field effect transistor. Hence, after this, we need to also discuss the construction and the principle of MOSFET. And based on that construction, again, we have the two types of the MOSFETs. One is the depletion MOSFETs, another one is enhanced MOSFETs. So in this session, we are going to discuss the construction and the characteristics of enhancement as well as the depletion modes. Then so this module 5 describes the FET amplifiers. So in these FET amplifiers, first we need to discuss the small signal model for the FET. And based on the small signal model, we need to describe the three different types of the amplifiers. Means if you observe the FET, we have the three terminals: source, drain, and gate. Hence, we need to discuss three different configurations. So hence, the analysis of common source, common drain, and the common gate JFET amplifiers. Then we'll also discuss the basic concepts of MOSFET amplifiers. So in this, again, we have some special purpose devices like Zener diode, and in that we need to discuss the construction of the Zener diode and how it is advantage compared with the PN diode. And then we'll discuss the characteristics. Based on these characteristics, where we are going to use this Zener diode, that is nothing but application, that is voltage regulator. Then we'll discuss the principle of operation, means how we are going to construct this silicon control rectifier and what are the characteristics of the silicon control rectifier, and then we'll discuss the applications of the silicon control rectifier like that. So another special purpose device is tunnel diode. So what are the doping levels are required to design the tunnel diode? So then what is the tunneling mechanism and what are the characteristics of this tunnel diode? We'll discuss by using this tunnel diode. So like that, we need another transistor is unijunction transistor. So here also we need to discuss the construction and the characteristics and some applications of this UJT. Then another special purpose device is directed diode. So these are the 5 modules related to electronic devices and circuits. So these are the, in this session we discussed that what are the course overview and what are the objectives and what are the outcomes, how these outcomes are related to our program outcomes. Then we also discussed that. So what are the modules we have for this electronic devices and circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.